the integral of cos t dt divided by the square root of 1 plus sine squared t from 0 to pi over 2. We're going to try to approach this problem two ways. If you'd like to attempt this problem, pause the video now and give it a try to resume when you're ready. Okay, so I have the cos t dt and sine t here color-coded for the u substitutions that we're going to make. These u substitutions will make the integral a bit easier. So, the first substitution we'll make, since cos of t is the derivative of sine t, is u equals sine t. Therefore, du equals cos t dt. So here's our substitution in action. Excuse me. It's the integral of du divided by square root of 1 plus u squared from sine of 0 to sine of pi over 2. And these bounds are just 0 and 1. Okay, so the integral in this form, you may be tempted to do a trigonometric substitution, so that we're going to do exactly that. We're going to use the identity 1 plus tan squared theta equals sec squared theta, and since the derivative of tan theta is sec theta, we're going to make the substitution tan theta equals u, therefore sec squared theta d theta equals du. Okay, so we have the integral of sec squared theta divided by square root of 1 plus tan squared theta d theta from tan inverse of 0 to tan inverse of 1. Those bounds are going to change to 0 and pi over 4, and the expression within the integral becomes sec squared theta divided by square root of sec squared theta, which is just sec theta in the denominator, and sec squared theta divided by sec of theta is sec theta. So we're ready to integrate. The integral of sec theta is ln absolute value of tan theta plus sec theta. So with the bounds, that's going to be the ln of tan pi over 4, ln absolute value tan pi over 4 plus sec pi over 4, minus ln absolute value tan 0 plus sec 0. Those values are going to be the ln of 1 plus square root of 2 minus the ln of 0 plus 1, which is just the ln of 1 plus square root of 2, which, if you would like to approximate, is roughly 0.8814. Okay, that's one method of approaching this problem. We're going to do another method, which is a little bit shorter, but it does require some knowledge of the hyperbolic trigonometric functions. So we're just going to skip to here, where we have our integral that we're solving is equal to the integral from 0 to 1 of du divided by square root 1 plus u squared. And we're going to make the substitution sinh v equals u, therefore cos v dv equals du. Alright, so the bounds will change to inverse sinh of 0 and inverse sinh of 1 of cos v dv divided by square root of 1 plus sinh squared v. And by this identity here, cos squared x equals 1 plus sinh squared x. So we have the integral inverse sinh of 0 is 0, and we're just going to leave this as inverse sinh of 1. we have the integral from these bounds of cosh v dv divided by the square root of cosh squared v, which is just cosh v. So we're just integrating from 0 to inverse sinh of 1 dv, which is inverse sinh of 1. And this just happens to be equal to the ln of 1 plus square root of 2. So this result actually uses a couple of facts about the hyperbolic trig functions. It doesn't prove them, but it does. It is under the implication that, for one thing, this identity is true. It's also using the fact that the inverse sinh of x is ln of 1 plus square root of x squared plus 1. And also the derivative of inverse sinh x is this. It's 1 over square root of 1 plus u squared. And that's it. Those are two methods for solving the integral from pi over 2 to 0 of cos t divided by square root of 1 plus sine squared t dt. Thanks a lot for watching. Tune in for the next video.